Alright, this is the 8th grade review for the Unit 8 test over probability. Alright, I do not think this test is very bad. The last class thought it was pretty easy as well, so we'll just move right into it. Alright, if we look at number 1, hopefully you have your paper at home if you're watching this on the YouTube, which none of you do. Alright, we have our spinner, and it's cut up into how many slices? 5. We've got 2, 3. Yes.
Can you see the left of the office, please?
Yes.
Thank you.
It's split into 2, 3, 5, 7, and 10. Alright, it wants to know 3 different probabilities based on this spinner. The first one is, what are the probability of it landing on an even number? Well, how many even numbers are there?
3 and 2.
2 out of... So you have a 2 in 5 chance of hitting an even number. So what does that mean for odd numbers?
3 and 5.
Last one is 2-digit numbers. How many 2-digit numbers are there?
1 and 5.
That's number 1 right there.
That's easy.
I agree, it's easy. Alright, yes, you do need to reduce on this test. If you don't, you won't be able to pick the right answer choice. Both. Short answer and multiple choice. Alright, number 2. A popular television game show gives $100,000 to contestants who successfully do one of the following. Roll a 6 on die. Roll the sum of 7 on 2 dice. And then a number greater than 4 on a dice. Alright, well 2 of these are easy. What are the chances of rolling a 6?
1 out of 6.
And what are the chances of rolling a number greater than 4?
3 out of 6.
Greater than 4.
What is that?
2 out of 6. Or 1/3. Alright, so now, the middle one is a little more difficult. Alright, we've got to figure out how many different combinations give us 7. Alright, and how many different combinations there are. Alright, so to do this, we're going to have to make a sample space. Now, this is where studying comes in handy, because we're going to make a sample space right now, but if you study, you shouldn't have to do it on Monday. Alright, so, what is the smallest possible outcome I can get? We're rolling 2 dice.
Or 2.
We roll a 1 and a 1, and a 1 and a 2, and a 1 and a 3, 1 and 4, 1 and 5, 1 and 6. That's every possibility if the first number is a 1. If the first dice is now a 2, you can go 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Alright? 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. Now how many different columns am I going to end up having?
6.
Alright, so we've got the 4 column, the 5 column, and the 6 column. So if I continue, if I wrote all these out, how many possible outcomes would we have?
36.
There'd be 36 total outcomes, because there are 6 columns, and each column has 6 different possibilities. Does that make sense to everybody?
Yeah.
Now, let's go through and talk about the ones that add up to 7. Are there any that add up to 7 in the first column? 1 and 6. What about in the second column? 2 and 5. Third column?
3 and 4.
Would there be one in the fourth column? 4 and 3, 5 and 2, and 6 and 1. It's important to remember there's a difference between 1 and 6 and 6 and 1. 1 and 6 means the first dice landed on 1 and the second dice landed on 6. 6 and 1 means instead of landing on the 1, the first dice landed on the 6. So they flipped places. Alright? So, there are 6 different ways to get 7. What does that reduce to? 1 over 6. So, based off these fractions that we've made, which one of these has the greatest chances of success?
The fourth.
Greater than 4, because if we look at our probabilities, we have 1 and 6, 1 and 6, 2 and 6. Well, 2 and 6 is greater, right? So this would be our best chances of winning. Luis Goodness. Alright, so again, that one took a lot of work, but if you study, you already know your sample space. You know there's a total of 36. I will tell you on this test review, I have changed all the numbers. So just studying the answers is not going to get you anywhere on this test. I've changed them all. However, this sample space doesn't change. So it doesn't matter if you study the sample space, you're still going to, understand that much. As far as the numbers that they include, I've changed them. All right, any questions on this one? All right. Number 3. The 8th grade class sold 400 raffle tickets for a country western concert, 300 raffle tickets for an MP3 player. Joe bought 10 tickets to the concert, 10 tickets for the MP3 player. What is the probability that he'll win both? Alright, so we've got 2 different probabilities, 2 different events occurring. What kind of probability is this then? This is complex probability. Alright, so the first event, what is the first event? In concert. Alright, how many tickets did he buy? 10 out of... And that reduces to what? 1 over 40. Second event was the MP3 player. How many tickets did he buy? Out of... Which reduces to 1 over 30. Since it's complex probability, we're going to multiply these together. Top times top, bottom times bottom. 1 times 1 is 1. 40 times 30 is 1,200. This is the probability of him winning both. Questions? Alright, a friend of Ann's did a random survey of the students in the students in the school and voted that and found that 55 out of 100 students planned to vote for Ann for the student council, which is the best estimate of the total votes Ann would receive if all 2,500 students in her school voted. Alright, this is an example of a problem where they give us the probability. What is the probability of her getting a vote?
55.
She has a 55 out of 100 chance of getting a vote based off of that survey. From here, the idea is that that proportion would stay the same even if we increase the total number of students, right? If we doubled the number of students, we should double the number of students voting for her. Right? So all we have to do here is set up a proportion. Right? On the top we had votes for her. Well, that's what we're solving for. On the bottom we had total number of votes. What did they tell us the total number of votes is going to be? 2,500. So what do I have to do to 10 to get 2,500? So up here, what am I going to do? Times 25. We got to do it the same thing. So 55 times 25. Alright.
Let's reduce this one.
This is the total number of votes that she should get. Everybody see how that works? All this is a proportion problem. We've done those plenty of times before. Again, remember these numbers are different. Alright, number 5. The probability of a female student being chosen to be on the drill team is 1 in 28. If there are 1,400 female students in the school, how many could be on the drill team? Alright, so what is the probability of getting on the drill team? Alright. We want to know how many will make it over, what's the total number of students? 1,400. Alright. So, here's what I want you to see. This top number is how many make it. We're solving for how many make it. This bottom number is total number and total number. That's why we set it up that way. So we need to figure out what we do to 28 to get 1,400. How do I figure that out? We're going to divide 1,400 divided by 28. 28 doesn't go into 14. How many times do you think it goes into 140?
5.
5 times 28 is actually 140. Alright, so we multiplied by 50 here. Alright. So what are we going to do up here? And what is 1 times 50? That's our answer. Questions on that one? Again, it's just setting up a proportion. Number 6. They want the probability of each of these different diagrams in decimal form. Alright, so here's the first one. Alright, so rather than going straight to decimal form, let's go ahead and do our fraction. What is our fraction here? 8 out of 10. There's 10 blocks, 8 of them are shaded. Alright, turn that into a decimal. What is 8 divided by 10?
0.8.
No, 0.2.
I had it now. I've always learned.
8 divided by 10 is 0.8. Alright, next one, we've got 2 circles filled in, 3 circles not filled in. Alright, what fraction is that? What is 2 divided by 5?
0.4.
4. We have a circle cut into 5 segments. It's not very good, circle. 3 of which are shaded. So what's the fraction? And my decimal?
0.6.
Alright, last one has 10 squares. 4 are not shaded. 6 are. So that gives me a fraction of 6 out of 10, which is 0.6. That's pretty easy. Now, the main point of this question is to show you that probability can be written as a decimal. I never have you do it. I normally have you do it as a fraction. It's usually going to be a fraction. And if it's not a fraction, it's 9 times out of 10 going to be a percentage. But it can be written as a decimal. Anything that can be written as a fraction or percent can also be written as a decimal. Alright, so this is what they're talking about here. But all you got to do is make the fraction turn it into a decimal. Shouldn't be too difficult. Alright. Yes, sir. Number 7. There are 625 students in Weaver Junior High School. Jimmy surveyed the 30 students in his English class regarding their favorite subject. 20 of the students responded that they liked history best. If his class is a representative sample of the entire school, about how many students in the school could Jimmy predict would choose history as their favorite. Alright, so based on the people he asked, what is the probability of kids picking history as their favorite subject?
2 out of 3.
Alright, it was 20 out of 30, which does reduce to 2 out of 3. So 2 out of the 3 kids are picking history. Now, how many kids are in the whole school? 625. And he wants to know how many of them would say history. Now, if we look at the problem, when it asks the question, it says about how many students in the school can Jimmy predict would choose the history as their favorite subject. Here's the key word there. About. Alright? We're going to estimate a little bit here. Alright, because we need to figure out how you get from 3 to 625. Again, this is just a proportion. To do that, we need to say 625 divided by 3. That's 2, 0, 8. And I'm going to start getting 0.33 repeating. So, if I want to estimate that to easier number, what can I say it is?
200.
We'll say 208, 200, something like that. I'll go ahead and say 208, get a real accurate answer. Alright. So up here, we're going to do the same thing. We're going to say times 208. Alright, well what's 2 times 208? 416. Now, I'll tell you on this one, 416 is not going to be an answer choice. Alright? But 400 will be. And 400 will be the closest answer choice. So since it's saying about how many, alright, 400 is almost 416. So it's a good guess that that would be your answer. Alright? This is the key word on that one. About. A boot. Alright. Number 8 says Rex has created a game that uses a spinner and a number cube. The spinner has an equal chance of landing on one of the 6 colors: red, blue, green, yellow, purple, and orange. The number cube has an equal chance of producing faces up labeled 1 through 6. Rex decides to draw a picture of the problem situation. What is the probability of a player landing on the color purple and rolling an even number? What's the probability of the first event? Landing on the color purple. What's the probability of the first event? Alright, yeah, there's 6 colors. One of them is purple. The second event, rolling an even number. What are your chances of rolling an even number? 3 out of 6, which reduces to 1/2. Alright, so now we can multiply these out and we'll get 1 over 12. That is your probability. Questions there? That's a pretty simple problem. Alright. Number 9. There are 7 girls and 6 boys in Mr. Peterson's physics class. Mr. Peterson wrote the name of each student on a 3x5 card and placed them in a sack. If 2 names are drawn from the sack at random without replacement, what is the probability of drawing a boy's name and then a girl's name? Key word here is without replacement. All right. Again, we've got 2 events happening. The first one is drawing a boy's name. What is the chances of drawing a boy's name?
6 out of 13.
There's 6 boys. There's 13 cards. This is our first event. Our second event, now we want a girl's names. Well, how many girls' names are there? And how many cards are in the back? 12. We did not replace the first card we drew out. It's part of the problem, says that we didn't replace it, right? So now there's only 12 cards in there. There's still 7 girl cards, but only 12 total cards. Now that we have this, we can go ahead and multiply it. 6 times 7 is 42. 13 times 12 is 156. Alright. This can be reduced by 6. So that would give me 7 over, what's 156 divided by 6?
Uh, 78.
26. So there's our answer. Questions on that? Alright. Mike has a stack of 10 cards randomly numbered from 1 to 10. If he randomly chooses 2 cards without replacing the first card drawn, what is the probability that he will pick 2 cards that are prime? Alright, so I need the numbers from 1 to 10 that are prime numbers. What would they be?
1, 2, 5, and 7.
1, 2, 3, 5, and 7. Any questions on what a prime number is? Okay. So, again, it says here that we are not replacing our first card. We still have 2 events. Our first draw and our second draw. What are the chances of drawing a prime number on our first draw? 5 out of 10. Alright. Which reduces down to 1 over 2. There are 10 total cards, 5 of them are prime. That's pretty simple math. Now on our second draw, how many prime numbers do we have now? 4. We drew 1 of them out. And how many cards are left in the bag? Or left in the stack? 9. Alright. We're going to multiply those together. You get 4 over 18. Or 2 over 9. Questions on that one? Make sure you know what a prime number is. It's pretty simple. Alright. On number 11. If you draw 2 cards from a deck of 52 cards without replacing the first card, what is the probability that you will draw a spade and then another spade? Alright, so again, 2 events. First and second. What are the chances of drawing a spade? How many spades are there?
13.
Out of?
52.
And what is that reduced to?
1 out of
1 out of 4. Which is pretty simple when you think about it. A fourth of those cards are spades, right? Alright, now, the second one. How many spades are left in the deck now?
12.
How many cards do the deck?
51.
Alright. Can that be reduced?
No.
It sure can.
Sure can.
It can be reduced by 3. What's 12 divided by 3?
4.
51 divided by 3.
20.
That'd be 60.
I'll just my guess. 15.
17. Alright, so now... What? No. Now we can go ahead and multiply across. You get 4 over, what's 17 times 4? 68. Alright. This can be reduced. Alright, we'll go 2. That gives me 2 over 34. Again, can be reduced by 2, which gives me 1 over 17. Right. There you go. Any questions? Good. The probability of selecting a piece of candy containing nuts in a box of assorted chocolates is 3 out of 5, or it should say 0.6. If you want to change it on your paper, it should say 0.6. Create a model that can be used to simulate this event. Alright, 0.6. Well, let's take a look at this. Let's go back a little ways. I've got two problems here that demonstrate 0.6 from earlier in the test. Y'all remember those? Those are two models that you could actually use. Of course, if you don't like them, you can do whatever you want to. You can say 3 out of 5, so there's 3 out of 5. You can do, you can do 5 circles and fill in 3 of them. Whatever you want to do. I just want a picture diagram that represents 0.6, the probability of 0.6. Alright?
We do a pie graph.
Yeah,
That's all I didn't know.
I think that's another example from earlier on in the test was a pie graph. Alright. Number 13. A bag contains 5 red marbles and 4 green marbles. What is the probability of selecting 1 green marble from the bag? Well, how many green marbles are there?
4.
How many total marbles are there?
Nah.
I do not think it gets much easier than that. That is pretty simple right there. Alright, this is our last problem, number 14. At the Griffin Middle School Carnival, 25 out of every 100 participants will win a door prize. Which of the following models could be used to simulate this event? Alright, 25 out of 100. So what is the probability that we're looking at? 1 out of 4, right? 25 out of 100 reduces to 1 over 4. First picture we have is dice. Alright, what is the probability of dice?
1 out of 6.
That didn't work. Alright, next we have 9 circles with 1 filled in. So what are the circles? We have 10 circles with 1 of them filled in. 1 out of 10. Next we have a spinner. We have 2 spinners actually. So there are 10 possibilities, and how many of them are winners?
1 out of 10.
On spinner 2, how many possibilities are there?
4.
And how many are winners?
1.
So that last one is the one we're looking for. Alright, that's the whole test.